Today we're going to take a look at similar figures, and a lot of what we're going to learn today is going to focus primarily on triangles. But before we start, we're going to look at just generic similar figures. What does that mean geometrically, and how can we apply it? So similar polygons are polygons that have congruent angles and proportional side lengths. So basically this means we have the same rigid shape but not necessarily the same size. So if you think about this with a square, right? We know squares have all 90-degree angles no matter what size they are. So those angles are never going to change, especially thinking back to that dilation unit in Module 2. But our side lengths will change accordingly. So we've got proportional side lengths and congruent angles. Those are our two pieces. And notice here they're going to use for the first time the symbol for similarity. So that little squiggle in geometry means similar. So it says ABCD is similar to EFGH. And because of the way they're listed, just like when we talked about congruence, A is listed first. That means angle A is the same as angle E. B is second, that's the same as F, and so on. Now this part right here gives us the ratios of the corresponding sides. So A over B, or AB rather, over FE or EF should be equal to BC over FG, should be the same as CD over GH, and last but not least, that should be the same as A to D over E to H. So we're matching up those corresponding sides. And that is what we refer to as an extended proportion, where we have multiple ratios that are equal. Scale factor is the ratio of the lengths of the corresponding sides. So if two figures are similar, there should be a consistent scale factor. So looking at this part here, it says determine whether these are similar or not. So we need to figure out, are these similar, yes or no? If they are, we have to write a similarity statement, where we're going to list the vertices in corresponding order and put that little squiggle in between. If they're similar, we also need to find the scale factor. So, looking at what we know, remember we have two things that have to happen. We have to have congruent angles, and we have to have proportional sides. So if I look at the angles, F is congruent to Z, J is congruent to W, all the way around. So I have the first part of this. All of my angles are congruent. So now I need to test, are my sides proportional? So is 16 over 20, this over this, truly equal to 12 over 15, which is also equal to 24 over 30, which is also equal to 20 over 25. Now notice every time I formed that, I went from the figure on the left to the figure on the right. We could have also done that in reverse order, from right to left, but we have to be consistent among the different ratios, so we can't bounce around. So I need to make sure that all four of these will simplify to the same fraction. So this first one simplifies to 4/5. The next one, 12 over 15, simplifies to 4 over 5. So far we're looking good. 24 over 30 simplifies to 4 over 5. Still looking good. And last but not least, 20 over 25 simplifies to 4 over 5. So now that they're all equal to each other, I don't need this question mark anymore, but I do have now proportional side lengths. So since I have both requirements for similarity, I'm going to say yes, these are similar figures, and I'm going to make sure I list them in corresponding order. So F, J, H, G is similar to Z, W, X, Y. And then it says find the scale factor from, and this is the important part, Z, Y, X, W to F, G, H, J. Now, what they've said is take any number from this figure and match it to any corresponding number in this figure. So what you've basically done is you've found the scale factor from left to right here. So what's going to happen if we go from right to left is it's going to simplify to the reciprocal of what we found. So our scale factor from right to left is 5/4. And the reason we knew to flip that is because of this statement right here. From ZYXW to FGHJ. So from right to left instead of left to right. So for future reference, we may want to look at what is that final piece. What's our final order? That way, once we simplify all of those fractions, we have that scale factor. So looking at our three components of our answer, we said yes, they were similar. We wrote our similarity statement right here, and then we identified the scale factor from right to left as they indicated. So for this one, it says in the diagram, triangle DEF is similar, right? This symbol right here tells me that they are similar to MNP. So what I want to make sure is, are these lined up? D corresponds to M, E is the second letter, corresponds to N. So yes, these are lined up in the same direction. So they want me to find the value of X. So with that, what I need to do is set up the proportion to help me get there. So 9 corresponds to 12 in the same way that 12 corresponds to 16 and in the same way that X corresponds to 20. Now, if you remember back to the day when we did the warm-ups with these ratio problems, if you've got 3 equivalent ratios or you've got a proportion with 3 ratios, you can choose which ones you want to focus on. So for me, I'm going to ignore the one in the middle because even though it's true the numbers are bigger, so I'm going to look at those smaller numbers. 9/12 should equal X/20. And at this point, I'm going to cross multiply and solve the same way I always do. So 180 equals 12x. Dividing 180 by 12 tells me that x is 15. So what I've just figured out is that this component is 15, and I've got that final piece. Now, if you remember back to when we talked about Pythagorean theorem and Pythagorean triples, we've got here kind of a disguised triple. 3 times 3, 3 times 4, and 3 times 5. Same thing on this side. We've got 4 times 3, 4 times 4, and 5 times 4. Now, I may not have noticed that at first glance, and in fact, you really wouldn't have to, because they don't tell you initially that this is a 90-degree angle, so I might not have looked for that from the beginning. But now that I've solved it, I can see that this is going to be a right triangle because those Pythagorean triples hold true. Just a little reminder there, not something essential for this question, but just a good review. So in the diagram, the figure on the left is similar to the figure on the right. What is the scale factor of, and pay attention to the order, the right to the left? So I need to pick a number from the right figure. I might start with 6. You can pick any side you want, as long as it has a corresponding value in the other figure. So I'm going to say my scale factor is 6 corresponds to 12, and then I'm going to simplify. So my scale factor is 1/2. So from right to left, 1 unit in QRST represents 2 units in ABCD. Then it says find the value of X. So looking at that, I can set up any corresponding ratio I want. I can stick with that the 12 and 6, or I can use 10 and 5, whatever I prefer. So if I say left to right equals left to right, I can cross multiply and find that X is 8. So I've done the 2 things they've asked. I found the scale factor and I solved for X. So perimeters of similar polygons will also have the same scale factor, which is kind of neat. So if I know that 2 figures are similar, their perimeters have the same ratio as the side lengths. So that's our key component here. You may want to pause this and jot this down. And remembering this fact is going to help save you a little bit of time on your upcoming test. It may save you a little bit of work. So it says find the scale factor of the figure on the right to the left Then find the value of x and find the perimeter of ABCDE. So I want to go from right to left. So scale factor, I might do 15 corresponds with 10. In fact, that's the only pair of numbers I already have, so in this case that would be my only choice, which is going to simplify to 3 over 2. So my scale factor says that for the figure on the right, there are 3 units for every 2 units on the figure on the left. Then I'm going to solve for x by saying x over 18, so I went left over right equals left over right, and I'm going to cross multiply here. I'm going to end up with 180 equals 15x, so x would be 12. And then lastly, they want me to find the perimeter. So I could set up a ratio to find BC, a ratio to find CD, and a ratio to find DE, but my faster option is going to say 10 over 15 equals an unknown perimeter for the left over the perimeter to the right. So I'm going to go ahead and add up all of my sides for the figure on the right. The perimeter here comes out to be 69 units. And then I'm going to cross multiply as normal. And I find that the perimeter should be 46 units. So again, I could have set up several different proportions and solved for those missing side lengths, but because the perimeters are proportional as well, I can simply use one ratio or one set of ratios that are proportional to find the perimeter. So now we're going to focus on triangles, and triangles have a couple of shortcuts to help us figure out are these similar or not. So if 2 angles of one triangle are congruent to 2 of another, then the triangles are similar. So this is going to be referred to from here on out as angle-angle similarity. So again, if 2 angles in one triangle are congruent to 2 in another, that's enough to conclude that these 2 triangles have to be congruent. Or sorry, not congruent. Back that up. Not congruent. These 2 triangles are similar. Now, since I brought up congruency here, let's pause for a second. Remember that congruence means that we have all sides congruent and all angles congruent, whereas similar means that we have congruent angles but proportional sides. So just as a reminder, there were 5 shortcuts for triangle congruence: side, 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 angle, side, angle, side, angle, 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 side, and HL. But again, these were to show that 2 triangles are exactly identical or congruent, and now we're focusing on, are these the same basic shape but different sizes? So similarity is a little bit different. Another theorem that we have for similarity is going to be side, side, side similarity, which says all 3 pairs of congruent, all 3 pairs of sides are proportional to one another. So, if we look at the example here, whatever this length is over this side here should be equal to whatever this length is here over this here. And last but not least, whatever this length is here over this length here. So if we have 3 pairs of proportional sides, that's enough to say we have side, side, side similarity. Last but not least, we have side, angle, side similarity. And if you remember back to those congruencies, whenever we had that sandwiching effect with the angle in between 2 sides or the sides in between 2 angles, that meant we were referring to the included angle. And the same thing is going to be true here. So, in this particular example, we've got this angle is congruent to this angle. So our 2 sides would have to be that this side over this side equals this side over this one. So that we have that angle that's included between the 2 sides. So this says, is either DEF or GHJ similar to the original figure ABC? Now in my example here, these are color-coded for you so that you can see what corresponds. But on a test or quiz, that won't be the case. So let's talk about how we figure that out. What I would do is I would start off from least to greatest for the first figure. So the first figure has 8, 12, and 16 as its 3 side lengths. Then I'm going to look at the next figure. I have 6, 9, and 12. So I've listed them both from least to greatest, and if they're similar, these should all be equal as proportions. So I'm going to test, is 8 over 6 the same thing as 12 over 9, the same thing as 16 over 12? And if I look at that, this is going to simplify to 4/3, 4/3, and 4/3. So yes, this one is for sure similar. But I also need to look at the other one. So again, I'm going to start with the original figure from least to greatest. I'm going to look at the current figure from least to greatest. And then I'm going to assess, are these ratios truly proportional? And in this case, I can see that the first and the third are exactly the same number. So they're going to simplify to 1, but this is not. So automatically, I can rule out this one is not similar to the first. So it just says, is either one of these similar? But I'm going to push us a step further. I want us to say triangle ABC is similar to triangle, and I want us to make sure, pardon the interruption, I want us to make sure we match these up. So if we look at how we went around this triangle, we went from smallest to medium to largest. So if I want to go across the smallest side, the medium side, and then back, right? That's that triangle ABC. When I name the other one, I want to do the same thing. I want to go across the small side first, then across the medium side, then back to complete that. So D, E, F is the order of my letters. Now those won't always be alphabetical, so be careful with that when you're writing your similarity statements. Last but not least, are these triangles similar? If so, write a similarity statement. And I want us to go a little further. I want you to state how you know. So remember, you have 3 shortcuts. We have angle, angle, we have side, 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 and we have side, angle, side. Those are our only 3 options. So the first and the third require that you have an angle that's congruent. So in the first picture, there's nothing that's stated about angles, but I do know all 3 pairs of sides. So if it's any of these, it's going to be side, 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 but I can't just assume that. I have to verify it. So for the one on the left, I've got 6, 8, and 10 as my 3 side lengths, smallest to largest. And then I have 9, 12, and 15. So I'm going to compare these 3 ratios and find out if they're proportional. So this simplifies to 2/3, 2/3, and 2/3. So yes, these are similar by side, side, side similarity. And it says to write a similarity statement. So now I'm going to match up the order here. One triangle is similar to another. So if I go across the small, across the medium, and across the large, that's triangle STU. And then over here, across the small, across the medium, across the large, that is XVW. And you don't have to do those from smallest to largest order, but what you do want to make sure is whatever order you pick, S always corresponds to X, T always corresponds to V, and U corresponds to W within their locations. So these are similar by side, 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 and then we've written our similarity statement. Now for part B, we've got to kind of be careful because our triangles here, we've got this smaller one where we have 8 and 12, but we also have a larger triangle that is 10 by 15, right? If we redraw that here, we've got a total of 10 and 15. So we want to make sure when we set up these ratios, we're looking at the entire triangles. And because they originally were overlapping, they both share angle K. So I can mark this angle here, and that smaller red triangle is congruent to the angle in the blue triangle. So if this is going to be anything, it's going to be side, angle, side. But again, I have to verify those numbers. So I want to see, is 8 over 10 truly equal to 12 over 15? Looking at the first one, they're both divisible by 2, so that's 4/5. And looking at the second one, they're both divisible by 3, so that is 4/5. So yes, the two sides are proportional. We have the angle in between. So yes, these are similar by side, angle, side, similarity. And then I want to write my similarity statement by saying KLP is similar to KMN, mimicking that order. Show that the two triangles are similar. So we want to show that ABE is similar to ACD. So again, we have one smaller triangle inside of a larger triangle. I see that they both already have 52 degrees and they have a shared angle at A. So these are similar by angle-angle similarity. Last but not least, here we have the vertical angles here and here, and we have parallel lines SR and TU, which means angle T is congruent to R, or we could say S is congruent to U. So this is also angle-angle similarity. Now notice there we do have all three pairs, but it only takes two of them to know that they're similar. So yes, those are similar by angle-angle. So tell what method you would use to show that the triangles are similar. So looking at this picture, again, we could add our vertical angles here. So then we have one pair of angles and two pairs of sides surrounding that angle. So it might be side, angle, side similarity, but I'm going to test that and make sure. So my smallest number on the left is 9. My smallest on the right is 15. Does that equal 18 over 30? And if I look at that, both of those 9 over 15 would simplify to 3/5. And so would 18 over 30. So yes, this is side, angle, side. Down at the bottom, we've got right angles for both. So my smallest number on the left over my smallest on the right, does that equal my biggest on the left over my biggest on the right? Looking at both of those, that 24 over 18 is going to simplify to 1 1/3, or if we're thinking about that as a improper fraction, that would be 4/3. And then on the right, 28 over 21 is going to simplify to the same thing. So this is similar again by side, angle, side. One pair of congruent angles and proportional sides. For this final one here, we want to prove that the triangle on the left is similar to the one on the right. Since these are a linear pair, I know I've got a 90-degree angle here as well. So in this case, I could use two different strategies. I could either use side, angle, side, or I could use side, side, side. So if we look at the triangle on the left from smallest to largest, we end up 12, 16, 20. And on the right, smallest to largest, 9, 12, 15. If I'm using side, 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 I would need to test that all of those ratios are the same. So looking at that, 12 over 9, those are both divisible by 3, so that becomes 4/3. The second ratio, they're both divisible by 4, so that becomes 4/3. And last but not least, they're both divisible by 5, which becomes 4/3. So yes, I could use side, side, side similarity, Or, like I said, I could use side angle side, but you want to be careful if you do that. If I'm looking at this triangle here, the two sides that surround it are 9 and 12, so smallest and largest. And then over here, if I'm looking at the triangle on the left, the smallest is 12, the largest is 16. So I would want to make sure that 9 over 12 is equal to 12 over 16, which it is. So I could say yes, also by side angle side. Either would work. Couple other examples here. Are these similar or not? So in the first case, we have 45 and 45. That's one pair of angles. And we have vertical angles. So this is yes by angle similarity. Then at the bottom, we've got two angles. 70 and 30 are going to match. And then I want to make sure by subtracting from 180 what those final angles are. So this would be 80 degrees. And then on the right side, if I take out the two I know, this would be 25 degrees. So I only have one angle pair, so these are not similar. The next one's here, same sort of thing. If I take out the 39 and the 90 from 180, that'll help me find that missing angle, which happens to be 51. So then I have angle similarity. And over here, I've got 180 minus those 268s that we have here and here, since that's isosceles, would leave me with 44. And on the right side, if I take out that 62 and divide by 2, I end up with 59 as those two angles. So these are not similar. Three final questions here, I believe, to look at in terms of are they similar or not. So we've got vertical angles here and here. Again, I do want to find those missing angles. So for this would be 100, which is indeed congruent to angle A. So this is angle similarity. For the next one, I know all of the side lengths. So I've got 2, 3, and 4 for the figure on the left. 3, 4.5, and 6. And I want to test, are those equal or not, to test for side. So looking at what information I have, all of those would simplify to 2/3. So this is yes by side similarity. Lastly, I've got my congruent angles and the two sides surrounding it. So 12 is the smallest on the left, 16 is the largest on the left. On the right, 15 is the smallest and 20 is the biggest. So I want to know, are those equal? So 12 over 15 and 16 over 20 both simplify to 4/5. So this is yes by side angle similarity. Guys, if you have any questions, please let me know. Have a great day.